In this video, we're going to talk about how to make predictions from a line of best fit. So to start with, let's just go back over how is it that we make a line of best fit. Remember, you're going to use this tool right here. And what you want to do is you want to make a line that goes through the data, follows that same general trend, that same steepness of my line. I want it about the same number of data points above and below my line. So if I drew a line in right here, while that has the same slope or the same amount of decrease as my data, I don't have the same number of data points above and below. So I would want to adjust that and draw it in the best I can between all of those points. And that would be a pretty good line of best fit. Now you might be able to come up with an even better one, but again, it doesn't have to be the exact line of fit, and there is an exact line of fit, the best case option, but in this lesson we're just estimating. So let's go ahead and draw our other practice. So if I wanted to draw in this line of best fit, is this a good line of fit? No. Hey, as the best I can above and below. Now, one thing that I want you to make sure that you know is that sometimes students think that you have to go through 0. Okay, and that's just not the case. Sometimes I really want to follow this trend, and it doesn't, my line to me doesn't look so steep, so I would make a line that looks like this. Okay. So again, it doesn't need to go through the origin, but it should follow the general trend and have roughly the same number of points above and below. Now, in order to answer questions, or even the purpose of me making this best fit line is to kind of create some conclusions and some generalizations about some data. So for this particular scatter plot, if I read up above, it says that it is showing the time spent watching TV and the amount of time spent doing homework. Now we know this is going to vary. Some students may watch a lot of TV and still spend some time doing homework, and there's some people that spend some time watching a lot of TV that still do no homework. So even for the number of hours, so if you look at my chart, even for the number of hours, even for 24 hours of watching TV in a week, that's going to vary how much they do homework. So there's no for sures with scatter plots, but we notice this downward trend. As I increase the number of hours spent watching TV, the number of hours spent doing homework decreases. So we would say that this has a negative correlation. This line right here has a negative slope. So how do I make some inferences or some predictions from this line of best fit? Well, if I just wanted to estimate, now I'm not saying predict, I'm saying estimate, like take a good stab at, if I looked at my chart and I said, about how many hours of homework does a person that spends 16 hours watching TV do? I would estimate that it's about 15 hours of homework a week. Okay, but that's just an estimate. It could be 15.1, it could be 14.9, and right now I'm not very sure. But notice down here, and this is what you want to use for every single problem. Without this equation, we're kind of lost on this assignment. This equation right here represents this line. This represents the y-intercept, or where it starts. So this point where it starts is 26.04 exactly. My slope is saying that it is negative. It's going down by negative 0.76 every 1 hour. So this line is represented by this equation, and this equation will help me answer each of these questions. And for a second, I'm just going to start with C, and we're going to answer these backwards. So on this problem, it says, what is the predicted time spent doing homework for a student who spends 15 hours watching TV? Well, I could estimate, but I really don't know where along this line it is, and I'm not really sure how high that is. So what I do is 15 hours stands for the X, 15 hours of TV. So in my equation, I'm going to take this X out and I'm going to replace it. So in my calculator, I'm going to type in negative 0.76 parentheses 15 plus 26.04. So negative 0.76, now I'll use this Desmos graphing calculator. So negative 0.76 times 15 and plus 26.04. So I would expect that person who watches 15 hours of television to do 14.64 hours of homework. So 14.64. Now that's pretty exact and close to what I would expect between 16 and 12, but I wouldn't just be able to estimate that. So you need to use the equation. Now, if I answer this next question, I'm going to answer the next question going up. What is the predicted time spent doing homework for a student who doesn't spend any time watching TV? Well, how many hours is no time? That's 0 hours. So I'm going to do the same thing. And just instead of 15, I'm going to put in a 0. Now, what I want you to notice is that I could take time plugging this into my calculator, but negative 0.76 times 0 is just 0. So my number of hours spent doing homework is 26.04. In fact, anytime you read a problem and it says they don't spend any time, or they spend $0, anytime my input is 0, that number on the end is always going to be my answer. That's my y-intercept. Now the last question says, for an increase of 1 hour spent watching television, what is the predicted decrease of time spent doing homework? Now this one tends to get a little bit tricky because I noticed that a lot of people just plug in a 1, right here. Notice it's not saying how much time is somebody spending watching TV for 1 hour. They're saying, what's the increase? If I go from 0 hours to watching TV to spending 1 hour watching TV, how much does my homework increase? Well, we know for 0 hours of homework, I do 26.04. So how much do I spend and how much is that increase? So I can plug in a 1 right here. So if I do plug in a 1, let's go to our calculator. Here's what I'd get. Negative 0.76 times 1 plus 26.04. And I get 25.28. Now remember that, 25.28. 25.28. Now, do not go ahead and put that up here. What I'm trying to calculate is how much is the increase? How much is the decrease to go from 26.04 to 25.28? What am I decreasing by? So I go to my calculator and do one last thing. So 26.04 minus 25.28. Make sure that's the right numbers. Yeah. And I can see that I have a decrease of 0.76. Now, that was quite a bit of work. Okay, and it would get kind of frustrating to do that again and again and again. So I want you to notice one thing. 0.76 is this number right here. My slope. Anytime it asks you about an increase of 1 hour, they're really asking you for the slope. This slope stands for my unit rate. And this is my unit rate. So the predicted decrease is 0.76. Now, be careful. If you do get this problem wrong, and reading the problem, I don't think you need to include it, but you might need to include a negative. But it does say what is the decrease, and the decrease is 0.76. So just be careful. You might need a negative. I don't think you will, but just check on that. Let's do one more problem to make sure we've got that. So what is the predicted amount of money spent on the entertainment of a student that doesn't work any hours? So predicted amount, no hours, 0 hours. So plugging in a 0, 1.84 times 0 plus 11.32 is 11.32. Now here's my increase question again. So again, it's not asking for what's my predicted amount. It's what is the predicted increase? How much is my line going up over time? Now, I'm going to predict that it's 1.84 because that's my slope. It's not writing 1.84, but let's go ahead and check. If I plug in a 1.84 times 1.84 times 1, and if I increase that by 11.32, sorry, flip it back to here, plus 11.32, I get 13.16. Now, since it increased from 11.32 to 13.16, I'm trying to find how much is that increase. Now, if I go back and I do that subtraction, you're going to find that it's 1.84. So yes, whenever it asks about what is this increase, I am looking directly at that slope. It will tell me that every time. The last question, what is the predicted amount of money for 8 hours? So I'm going to go ahead and plug in an 8. 1.84 times by 8 plus 11.32. So let's go ahead and come in here. Now, one thing nice about Desmos is you can, if you want to arrow over and just change that one number, you can. So 26.04. So for 8 hours, I would expect to spend 26.04 cents on entertainment. All right, that is how to make predictions, exact predictions from a best fit line. If you have any questions, please reach out and have a great day.